presentation sessions. I request all the presenters, session chairs, and participants to kindly proceed to their respective venues as mentioned in the conference schedule. Before we begin, it's my privilege to welcome our esteemed session chairs. First, we have Dr. Sayyam Sharma sir is working as Associate Professor in Mechanical Engineering in Meerut Institute of Technology. He did his PhD in Mechanical Engineering from NIT Bhopal. He has a vast experience in industry and teaching. He has worked with EWSAR Steels Limited. He has a various publication in SCI and Scopus. Please welcome him with a huge round of applause. Next, we have Dr. Kriti Agarwal ma'am, PhD in Mathematics from Banasthali Vidyapit University, MSc in Mathematics from DAV Degree College, BSc in Mathematics, Physics, Statistics from SD Degree College. She has teaching experience of 20 years, Scopus paper 3 published, 3 accepted in Scopus, 2 paper communicated in Scopus. Please welcome her with a huge round of applause. Next, we have Dr. Suneet Shukla sir. He did BTech from IIT Delhi in 1983, went to USA for postgraduate studies on full scholarship, completed MS in computer science from Illinois Institute of Technology, Chicago, worked in US for 4 years, come back to India, served as HOD IT in IFTM University, Muradabad, and taught there in CSE IT for 17 years. Completed PhD from IFTM University in 2018. Have been with MIT Meerut for last 2 years. Research areas include mobile ad hoc networks, data mining, and soft computing. Have published more than 10 research papers in international journals. Have a passion for teaching and has been constantly acknowledged by the students. Please welcome him with a huge round of applause. Next, we have Mr. Ankit Gupta, sir, Associate Professor, Department of Pharmacy, MIT Meerut. Qualification M.Pharm, PhD pursuing specialization pharmaceutical chemistry, two papers published and 5 presented in conference. Please give a huge round of applause. It's my privilege to introduce Dr. Pushpendra Kumar, sir, Associate Professor, Department of Physics. Sir has completed his MSc in Physics 2005 and MPhil in Physics 2006 from CCS University, Meerut. He qualified the prestigious CSIR UGC NET, securing an All India rank of 101 and also qualified the GATE examination. He was awarded his PhD in Physics in 2016 from CCS University, Meerut. With 19 years of rich teaching experience, Sir has made significant contributions to academics, research, and student mentorship. Please give a huge round of applause. May I now invite Ms. Alice Sharma, author of the paper titled Saliva-Based Diagnosis Tools for Non-Invasive Disease Detection. Alice. Next we have Nishant, Saurabh Agarwal and Deep Shri, author of the paper titled An Integrative Framework for Identifying Drivers and Barriers in Spare Parts Management in India Auto Industry. Please welcome them with a huge round of applause.
मिनट पे चलेगा तो ठीक चलेगा तो इनके पास चलेगा तैयारी का सब तो क्या है मेल आईडी फॉरवर्ड कर मेल कर दी के अंदर मेरा आईडी कॉलेज की मेल आईडी कौन से
जो भी एक मेल आईडी
कोई भी एक मेल आईडी इस पे होगा ना नहीं वो तो वो करेंगे हमारी तो जैसे कॉलेज की वो है यूट्यूब वाली सब लोग उस मेल आईडी पे भेज देंगे ना वो तो इनको पता होगा ना उसमें होगी वो शायद वो यूट्यूब वाली सोशल से नहीं खोल देंगे ना यहाँ पे खुली रहती है ना उनकी आईटी वाले जो यहाँ के वो बंदे हैं वो खोलेंगे आईटी वाले आदित्य खोल देंगे आदित्य खोल देंगे
Good afternoon, everyone. For the next 5 to 7 minutes, I will be giving a presentation on integrative framework for identifying the drivers and barriers for space product management, in particularly the Indian auto. I will be covering my topic. So I will cover the brief on drivers and the barriers with the methodology, result findings, and brief implications before with the topic. If we see the spare part management is the planning, monitoring, and control of the man, material, process, spare parts, and the information flow in order to support various repair and maintenance activities. It has got a very direct connect with the equipment and system availability, the production continuity, and the customer satisfaction. The unavailability of spare part, as we know, is directly caused the interruption caused, the additional delivery caused due to the urgency of the material lost, business cost, the reduced customer faith in that particular matter, and it is almost implemented in across the industry, whether it's a manufacturing industry, aerospace, automotive, energy, or the service sector. If we see, it has become more critical in the manufacturing and service industry when the spare part become more complex and the customer expectation are growing high in the service industry, and emerging technologies are again make it more complex. So despite the strategic and the tactical importance of these spare parts, the various challenges are there. So because of these challenges are mainly because of the issues like the uneven demand pattern, long lead times, inventory obsolescence, forecasting difficulty, complex supply chains. So now we have got opportunities of technology in the field. With that, those digital advanced technology, we have got opportunities due to the data analytics, the predictive maintenance, supply chain integration. So now there is a need to identify these drivers and barriers in order to support the spare part management to get a efficient and a sustainable spare part management. So this basically work provide an integrative framework to identify, prioritize, and see the effect of these drivers and barriers to progress on a spare part management. If we see in this field, work is done at a bit. So this, but the empirical work with the structure identification, categorization, interaction between these drivers and barriers is missing. Some simultaneous evaluation is also missing at places, and there is a gap between the analytical models which have been provided and the practical implementation which has been seen. So I've already covered this. Will cover the identification and the evaluation and covered with the indication. These are the few the drivers which are finally structured and categorized. The four are the strategic, technical, technological, operational, and sustainability. And with that, like one strategic, the further dimension was evaluated. This is mainly I'll brief in a methodology. So like strategic agility, customer satisfaction, competitive advantage. So like every driver is divided into subcategory for the purpose of survey and detailing. So initially some more dimensions were there, but after the survey, some because of the criteria were reduced. So same goes with the barrier. With the four types of major barrier were identified: organizational, technological, operational, and economic. And the dimensions are also seen like in technological way about the inadequate digital infrastructure, system integration. So as shown in a figure, these dimensions are there with each barrier. So the research was mainly involved. These barriers were identified with the dimension and then converted to a structured questionnaire. And those questionnaire was sent to the particular automobile industry experts. And based on the Leica, their suggestions were taken. And based on their prioritization and their importance to each with the criteria taken, like this is a table from which the statistical analysis were done using a Delphi technique and the SPSS tool were used for that. So based on the priority, the factors were chosen, and as you can see the priority is given. If we see among the drivers, the first is the strategic driver comes on a priority, then the technical driver followed by organization and the sustainability. And among the driver, the dimension, the strategic ability is main, then the competitive advantage. So likewise, the rank is also was evaluated. So basically, the statistical method is very known to all was used. Mean was giving the importance level, and the coefficient of variation was given the consider. Delphi technique is used basically for with a two-step method to improve the consensus due to its iteration technique. So this is what I have already explained in the previous table. So again, if we go further into the dimension, the real-time information exchange, data analytics capability, these are the technical thing. And then coming to the operational drivers. So in this, we have seen the operational drivers are also contributing towards the sustainability and the circularity. So sustainability, though the drivers has got slightly lower ranking, but it is now progressing further. Now coming to the barriers, these are the barriers I have already told you. With the ranking of that, the technical and the organization barrier are number 1 and 2, and the economic and the other barriers are after that. So again, the detailing of the finding is almost based on these tables, and again the correlation was also checked between these drivers and barriers, and like the values are, we can see that 0.775, the technical and the organizational barriers are has got high correlationship. The value like 0.7 to 0.625. So the sustainability with the organization barrier, there was a low, the moderate relationship, and the lower values are showing the lower like the sustainability drivers. So same way it happens in the drivers also. The interrelationship basically is required. When you need a integrated solution. So which I'll cover slightly later. But so these are the findings which I have already shown on the table, which is on a priority. And if we see the implication of this work is mainly a theoretically, it is giving a structure, understanding a lot of literature and the work give for the further this thing. And the strategic operational sustainability consideration is again can be taken with this work. From a socio-technical perspective, the digital transformation interconnect with the technical infra organization factors, all those drivers and barriers are presented. and the advanced technologies, use of that, strategic roadmap, investments, how what should we prioritize, and all those things are organization readiness, what all drivers and barriers are there. So these things are there which can be practically used by the managers in the industry. So to conclude, I can say the work has identified, prioritized, and examined the various drivers and the barriers, and mainly the influencing the mainly the spare part management is the industry, specifically the auto industry. The strategy I've already told you, the competitive advantage, customer satisfaction, and the strategic agility is the main dimension of strategic drivers. And technical, again, real-time information, data analytics, organization ability. They mainly focus on improving the visibility in the organization, the responsiveness, and decision-making capability enhancement. And significant barriers were identified as integration issues, mainly with the legacy system with the new system, the workforce skills there, then the inadequate infra for the technical thing, and the investment to the initial investments in the technology. So now there is a need to have a spare part management with the to improve these drivers and barriers. Basically, we need to have an integrated approach where the strategic commitment is there with the technical capability and with the organization will to reach a goal. Future work can also be done with these barriers. With the large empirical samples can be taken, the advanced quantitative techniques can be utilized, and the important then it can be calculated and seen that at different stage of the industrial digital maturity can be worked. Thank you.
Thank you so much, sir. Next, we have Aman Kumar, author of the paper titled DFT Assessment for Wide Bandgap Optoelectronics and UV Photo Detection. Next, we have Nishant, Saurabh Agarwal, and Deep Shri, author of the paper titled Investigating the Issues and Challenges to Industry 4.0 Adoption and Implementation for Spare Parts Management, Indian Auto Industry. Please give a huge. All the participants, please send your PPT on conference ID, mail ID. Conference ICRIST@MIT Meerut.ac.in.
Good afternoon, sir. Again, continuing the same direction in the spare part management, this talk is mainly I'll be covering the investigating the various issues and the challenges of the adoption and the implementation of Industry 4 technology in spare part management. Again, with a specific to the Indian auto industry. Again, I'll cover the talk under the following heads. I'll cover some of the adoption and implementation challenges of Industry 4 into a spare part management with some methodology and result findings, some implication before concluding the talk. If you see, I've already told you spare part management again, it's a critical function related to the availability, the operational continuity, and the customer confidence with optimization of the life cycle cost, the LCC. So now coming to the Industry 4, which is a new concept, though everybody must be knowing about that, it's mainly focused on a system and the process automation, mostly on a digitization, data analytics, mainly to overcome the ongoing technological challenges of the industry. And spare part management, I have already seen it has got its own capability. Now it can be benefited by this Industry 4 technologies. As we know, Industry 4 technologies are Internet of Things, AI, ML, AR, VR, digital twins, additive manufacturing, and big data analytics. Like, so a lot of technologies are there in the envelope of the industry 4. So these industry 4 technology, how it can be utilized for effective and sustainable, mainly the spare part management. So that we have seen, and the benefits of these technology integration will be will have more dynamic, resilient spare part management with operational efficiency and the again customer centric, which is very important in case of a spare part. And despite these all benefits, but we have got a lot of challenges which is there during the adaptation and the implementation of this industry 4 technologies into a spare part management. So broadly, again, it is categorized into 4 categories: the technical, financial, organizational, and the regulatory. So mainly these challenges are obstructing the growth of the organization with the competitiveness in the revenue growth hindrance. So again, there is a need to address, to first find out these challenges, categorize them, and to address these challenges to get the benefit and the sustainability in the, at least in the present scenario. So again, this work will is there to identify, categorize, and evaluate the critical challenges which is there in the industry for implementation in the spare part management. So this work will be helpful for the practitioner, society, academia towards developing the effective implementation techniques, strategies for the industry. So again, this again a lot of gaps were seen. The industry 4, a lot of work has been done actually in industry 4, but industry 4 integration with the spare part management is very few studies have taken place by the people. So that is why this work is on, and wherever they have taken, it was mostly on an isolated technology, only on one technology, not on an integration base. And so the comprehensive solutions were not there for the empirical approach. So this work has been taken in this direction. The again identification, classification, evaluation, and the recommendation part is there. So these challenges again divided into a 5 categories: the technical, organizational, and HR, and legal, regulatory, and economic must be there. So again, if you see the slide is not shown, the lower part is the 6 dimension of each of the challenges, which has been again worked out in the same verified technique. The detailed questionnaire was prepared to get the, after literature review this and the analysis and the discussion, these factors in the dimension were identified, and then they were converted into a questionnaire. Questionnaire was sent and discussion were done, and then out of those, as per the parameters, the prime factors and the prime dimension were taken, which I have shown on this slide, slide 6 for each. And then on those, the values were taken again with the industry, and they've given their values for their importance. Same case for the Delphi technique, same 2-tier system is used. Well, 15 actually experts were taken, those are actually working in the industry and working on industry 4 technology. So based on that, again the same statistical analysis was done, values were taken, and the criteria was set, and based on that criteria, again the values of these 30 parameters were seen, and again, so with this two again iterative technique, we got a more convergence. Phase 1, we have given the questionnaire, taken back the feedback, and those anonymous thing again shared with those 15 experts, and after that we have got slightly better consensus on the results. So more validity basically. So now these are the values where we have seen the technical challenges are more prominent, followed by the organizational and the HR challenge, followed by the economic, then the operational and the quality challenges, and the finally the legal and the regulatory, which we are not gone though into the detail. So again, these findings is telling about those priorities, all 5, the slightly in detail. So again, coming to the implication part, how it is useful actually. So we can, the industries can prioritize their technical thing based on technical parameters. They can work on a cyber security, which is the main challenge actually in the industry. They can focus on towards the organization thing. They can more focus on upskilling and the training of their employee towards the industry technologies like AI and all those things. And again, the organization bill is again a major challenge which can be resolved by using a drop-driven approach in the industry. Data quality improvement, inventory visibility, it's again the operational challenges which needs to be handled. Financial part is industry has got a initial investment issue, so they can go phase-wise in a phase manner, with the implementation and see the cost by doing the cost benefit analysis at each stage and with compare with the risk of that. So the policymaker can also support this adaptation and implementation of industry 4 by giving a lot of schemes towards this and with the incentives. So finally, the evaluation, the challenges are identified. These challenges are categorized so that each field can be seen independently as well as comprehensively, because you can only find a solution for these by doing a comprehensive, finding a comprehensive and a balanced solution. So approach I have already briefed you, and all the challenges can be handled which are most significant. And again, the larger expert panel can be taken in the further studies to have more, and it can be done across the industry and maybe across the globe to have a broader perspective. And the other technique, quantitative models, can be used. Thank you.
Thank you so much, sir. It was such a wonderful presentation. Next, we have Rohit Kumar, Aman Kumar. Next, we have Prashant Yadav, Maninder. Next, we have Megha Varmal, Mohammad Asif Siddiqui, Afifa. Author of the paper titled Isolation of LDPE Microbes from the Waste Yard of a Polythene Manufacturing Industry. Please welcome her with a huge round of applause. Good afternoon to all. Myself, Megha Verma. My presentation is on biodegradation of LDP microbes from waste yard of polythene manufacturing industry. The amount of plastic pollution is growing daily, which is determined to wildlife, natural environment and the people. The accumulation of the plastic in the land and the ocean is currently the most threatened issues in the world, mostly due to the fact that it does not decompose. The majority of plastic manufacturing and a single-use plastic, which along with a three-hour culture contribute to the accumulation of the plastic waste and the pollution, as well as the depletions of an important resources. Plastic that are improperly disposed of represent a serious threat to the environment and may even endanger the life. Globally, some 275 million tons of plastic trash are produced year, of which 4.8 million to 12.7 million tons are dumped into the ocean. Non-biodegradable plastic that have accumulated and are regarded as a solid waste on the surface of the earth are mistaken for the food by terrestrial animals like cow and buffaloes, which led to the animal death. Toxic substance includes the bisphenol A, polychlorinate, biphenyl, nonphenyl, dichloride phenyl, trichlorine, polycyclic aromatic hydrocarbons, polybrominated accumulates in the oceans as a result of the disposal of plastic trash. These chemicals have been linked to the reproductive issues in the marine organism as well as the indirections and the gastrointestinal obstruction. My objective is isolation, screening, and the characterizations of LDP degrading microbe from the waste yard of the polymer manufacturing industry. Growth profiling of the selected bacteria consortia in the absence and the presence of quantum dots nanoparticle. Studying the influence of nanoparticle on LDP biodegradation under in vitro condition, morphological, spectral, and the thermal analysis of biodegraded product. This is a soil sample collection site from where I collected the soil and the polythene sample. This is a Krishnanagar, Sonda Road, Rajbala, then the polythene industry, then Subhadri University ground, Meerut, and Mariam Road and Shani Road from Ghaziabad. Soil collected from the different site are placed in a different Patrick plates. Polythene collected from the different site are cut into the small pieces and placed over the soil. Now these soil media containing the polythene pieces are incubated for the 15 days at temperature 37. Now these polythene pieces are picked out from the soil plate with the help of this forceps and placed over the different agar plate. This step is performed in a laminar airflow to avoid the contamination, and the plates are plates incubated at 37 degrees Celsius. After that, preparing the fungus specific media, that is SDA. Now pour the SDA media in a sterilized Patrick plate and let it solidify for 15 minutes. Take out the agar plates from the incubator and placed in a laminar flow. With the help of the stimulating loop, take the growth from the sample from the agar plate media and strike over the surface of the SDA media, and then SDA media are incubated at 37 degrees Celsius. These are the isolates, microscopic view of the isolates. The aspergillus isolates exhibit sustainable potential for LDP biodegradation, suggesting that aspergillus isolates can be used as a LDP as a carbon source via extracellular enzymatic activity. Based on these results, indigenous fungal isolates from the plastic contaminated area may be used as a biological agents in the degradations of the polythene. These findings will serve as the basics for the future molecular characterizations and the large-scale applications of LDP degrading microorganisms towards the promotion of sustainable management of plastic waste and the environmental bioremediations. Thank you. Thank you so much. Next we have Subhanvita Chatterjee of Subhanvita Chatterjee. Next we have Rishabh Gupta, Dr. Rahul Kaushik, Dr. Adesh K. Arya, author of the paper titled Lead-Free Solar Cell Simulation with Now we have Dr. Rajveer Singh Tyagi sir to kindly present his presentations.
Good afternoon to everyone. My name is Raj. I was working in a in the field. I would like to discuss many things here. Uh, Electron impact ionization means are basically work was on E to E process where ionization means complete removal of electron from any atom. It may be called the ionization threshold to some kind of energy. First, incident electron which it will come, it will strike. In the process, I'll discuss many things. Before I start it, I would like to know something about collision, what kind of collisions we are taking. Actually, in the EM wave, basically, there are three kind of interactions which are very important for us. First is electron matter interaction. Another is photon and matter interaction. And the third one is any ion beam that interact with the material. The basic idea between is that whenever any electron will target it on the material, the ejected electron which is after coming after the scattering, it will take the signature of the characteristics of the material. That is why the all properties we will help you study this. So okay, आयनाइजेशन प्रोसेस को समझने के लिए हम सबसे पहले एक साधारण सा एक प्रक्रिया देखते हैं। इसमें कोई एक डाई एटॉमिक मॉलिक्यूल ए बी है, एक इंसिडेंट इलेक्ट्रॉन आया, आने के बाद टकराया और टकराने के बाद में आपके पास ए बी प्लस प्रोसेस की प्रक्रिया बनी। फिर दूसरे में आपके पास अनदर इलेक्ट्रॉन, ये क्या काम कर सकता है, या तो वो एक इलेक्ट्रॉन को लेके जा सकता है और उसके साथ साथ में कोई जो दूसरी स्पीसीज है एटम उसे भी अपने साथ लेके जा सकता है, बशर्ते उसके पास इंसिडेंट की एनर्जी सफिशिएंट। इन दोनों प्रक्रियाओं के अगर मैं देखूं, the probability of occurring any event is called as the differential ionization cross sections. We are to calculate it. So we have the total cross section which is the sum of what kind of events actually taking place. Ionization mechanism, as I have discussed with you all, that ionization mechanism is the process where you can have that electron is being escape from the atomic ground state to infinity and goes to infinity. In the process, E plus AB दो इलेक्ट्रॉन एक साथ निकल सकते हैं। अब थोड़ा सा मैं आपको और थोड़ा सा डिटेल की तरफ लेके जाना चाहूंगा। एटॉमिक में बोर्ड थ्योरी हम लोग पढ़े हैं, 2013 में 100 साल पूरे हुए थे बोर्ड थ्योरी के। तब ये मैंने थोड़ा सा इसमें आइडिया में लगाया था और रिलेटिविस्टिक इंट्रोडक्शन कराने की मैंने एक आइडिया लगाया था। तो उस वक्त हमारे मन में ये चल रहा था कि एक इलेक्ट्रॉन विच इज रिवॉल्विंग अराउंड द एटम which is revolving around the nucleus have the velocity of c z by 137 and c is the speed of light, z is the atomic number and 137 1 upon 130 Magellan constant in the terminology. So we have studied all these things. So process how it will take places are important in the sense if we have kind of dissociative ionization, dissociative multi-ionizations. In the single slit channel there are various kind of channels. We have many ions, cations, anions, maybe kind of atoms. See, this theory is applicable. The most beautiful part of the work is it is applicable for atom, ion, molecules, uh, clusters, clusters of fullerenes, and many things. We are nowadays we people are working in the area of the biomolecules. RNA, DNA. It will totally change the whole scenario if we will study more in detail. Determination technique, there are the, in the real world, what the people who are doing in the work, the experimental technique, that is mass spectrometry. Mass spectrometric techniques is basically when a charged particle enter in a magnetic field, it feels for Lorentz force. If QVB sin theta is equal to what is the kind of force? Centripetal force. So Q by M ratio, the trajectory of the charged particle can be localized in the such way. And the physics behind it is the mass spectroscopy technique. Another is time of flight mass spectrometry, double Foxy. These are the various people who are working in the area. Fast neutral beam technique, which is in the working in the TIFR, Professor Lokesh Trivedi, which are doing in the same region. Electron student experiment in the Calcutta, SN Bose, and the theoretical work, R matrix, Professor Baluja Saab has worked in this area. सचिन गुप्ता जी अच्छे से जानते हैं, तो आई नो दिस। जो आपकी स्पेरिकल कॉम्प्लेक्स ऑप्टिकल पोटेंशियल मॉडल है, ये गुजरात में एक ग्रुप है, ये पीपल आर वर्किंग डीएम अप्रोच बाइनरी एनकाउंटर, और जैन एंड खरे साहब, प्रोफेसर खरे हमारे ही आइडिया मलिक साहब के और हमारे दोनों के सबके गुरु थे, तो वहाँ पे यूनिवर्सिटी में, तो उसी अप्रोच को हमने थोड़ा सा और आगे बढ़ाया। हालांकि इसमें और भी बहुत सारी गुंजाइश है काम करने की, because in the technique what we have done, we have considered the electron is to be considered as the classical picture, or you may say that the Maxwell-Boltzmann statistics is to be followed there. If we shall do the relativistic effect, because the electron is revolving with the speed of comparable to the light, so we can do much more better. So okay, this is the theoretical technique by which I go in the detail. Is a quantum mechanical approximations. There are what physicists normally do. We choose a simple problem, apply some kind of approximation, make problem more easier and easier and then we are doing the work. Okay, I understand that. So I'm looking for fast. I would like to show the only result. So these are the some results. इस स्लाइड में सबसे केवल मैंने 4 भी लाइन लिखी है, चारों लाइन को मैं एक बार जरूर बताना चाहूंगा। दिस इज द एक्सट्रापोलेशन ऑफ द टाइम differential cross sections, which is the function of energy. We can extend, suppose we have the work ionization threshold to 2 keV, 2000 electron volt, and if you wish to extend it to the some particular range of the energy, we can using this particular extrapolations. Another is there is a beta P2 cos theta, that is your angular behavior of cross section. It is in the terms of the Legendre polynomial. Actually, the differential cross sections dance according to the cross sections area is according to the Pnx, which is Pnx is the Legendre polynomial. Third last, the most important thing is the rate coefficient. With the help of rate coefficient, we can find out how the plasma ionization cross section structures can take places. So this work is another interesting way. Conclusion is simple. We have worked in this area approximately, वो 6-7 साल का काम 5-7 मिनट में निकाल लेना बड़ा मुश्किल काम है, हालांकि आप सभी लोगों के लिए बड़ा मुश्किल होता होगा, मुझे तो शुरू करना ही मुश्किल रहेगा। The same issues with the all researchers, and the person who has done work in the region is very complicated task to. Ionization of molecule by electron impact is the most important and fundamental process in collision physics. Every interaction means the basic idea which I have concluded in the previous, the scattered electron will have the signature of the material of the atom, the target material. So ionization leading to secondary electron emission is another stage in the mechanism of radiation damage to DNA biomolecules induced by primary ionizing radiation. So, such as investigation based star, DNA, and peptides component, we can change the ideas. It may help to the idea. These are the research that we have paper in radiation physics, Journal of Physical Chemistry A, JPCA, and there are another paper in the international research which we have published. And thanks to Sachin Gupta ji, Malik Saab, both we made a motivations to come here, and you both are my inspirations to come up this every time.
Thank you so much, sir. Next, we have Subhanvita Chatterjee, author of the paper titled Study of MWAR Quantum Cascade Laser Applications in Infrared Countermeasure System. Please welcome her with a huge round of applause.
Good afternoon to everybody present here. Myself, Shubhanvita Chatterjee from Amity University, BSc Physics, Honors plus Honors Research, 4th year. So my topic is study of MWIR quantum cascade laser applications in infrared countermeasure systems. So about the topic, I did my work on the MWIR quantum cascade lasers, which are the advanced semiconductors. They're not like the conventional lasers because the conventional lasers are basically electron hole the combinations, but the quantum cascade lasers are the inter subband transitions in the uh, gallium arsenic or the aluminum gallium arsenic quantum wells. So the work studies the design and the performance of the MWIR QCLs in 4.6 micrometer, and it's a more theoretical and simulation based research work rather than experimental. So my research area includes semiconductor physics, quantum electronics, photonics, optoelectronic, and defense technology. Why I chose this topic is because modern aircraft face a lot of threats because it is very easy to detect a missile incoming into our country. But with this, we can basically fake another missile in which they'll not be able to detect our actual missile from our country. So first we didn't want to use the normal lasers because it had limited wavelength tunability, lower efficiency and higher power consumption. But in the QCL that we use, they have high output power, and it is a more compact size, and it has fast modulation capability. My research objective is to study the operating principle of the quantum cascade laser and to understand the quantum confinement and inter-subband transitions. I analyzed the gas or gas quantum well structures, and then I simulated them with MATLAB simulations, and then I investigated the role of MWIR QCLs in the defense technology. So my methodology was to first I started with literature review, then I went into the basics of quantum mechanics, then I went into details of quantum well design. I simulated the gas and gas energy bands. Then I did the rate equation modeling of 3-level and 4-level QCLs. Then I simulated in the MATLAB. Then I analyzed the results, and then I made sure it was more like it was suitable for the defense technology. The results and findings. So population inversion increases with injection current. The population inversion is basically the electrons are more in the upper laser level than the lower laser level. The gas and gas quantum wells support efficient inter-subband transitions, which is suitable for the quantum cascade lasers. And rich waveguides and FV cavities reduce the optical losses. And MWIR operation, they usually operate at 4.6 micrometer, which is uh, which is within the atmospheric transmission window, making it ideal for the defense technology. So my innovation is basically it is an integrated work of a lot of physics fields, not just like in not just focus on the quantum physics. So I have gone through the quantum confinement theory, the quantum well engineering, rate equation modeling, MATLAB based numerical simulations, device optimization, applications which is related to defense technology. So the impact of my work on the society is they have improved the national security, protection of the military aircraft, better environmental monitoring, and safer industrial gas detection, and it promotes advanced semiconductor research. So it is the use in industry is basically in defense. It's used in the direct intra countermeasure systems. In aerospace, it's used in aircraft protection. In chemical industries, it's used for gas sensing. In medical, it's used for breath analysis. And in environmental, it's for pollution monitoring. And in research, it's for infrared spectroscopy. So applications is fighter aircraft, military helicopter, transport aircraft, naval vessels, and unmanned aerial vehicles. So my conclusion is that so basically gas and ALGAS quantum wells are suitable for NWIR quantum cascade lasers which operate in 4.6 micrometer. Future scope is basically you can like it's basically into advanced semiconductors. You can study semiconductors in advance. So yeah, thank you.
Thank you so much, ma'am. Next we have Mr. Rishabh Gupta, author of the paper titled Lead-Free Solar Cell Simulation with SCAPS. Please welcome him with a huge round of applause.
Good afternoon, everyone. Respected chairperson of this session, distinguished professors, researchers, and fellow participants. My name is Rishabh Gupta, research scholar from Haridwar University, Uttarakhand. First of all, I would like to thank organizers of this conference to provide me the opportunity to present my work here. My topic is lead-free solar cell simulation with SCAPS 1D. This work has been carried out under the guidance of Dr. Adesh K. Arya from Department of Physics, Haridwar University, and co-guidance of Dr. Rahul Kaushik from the Department of Physics, HBM PG College, Raisi, Haridwar. So let's begin. As we all know that the world's population is increasing day by day, because of this energy demand is also increasing in similar manner. Right now we mostly rely on fossil fuels like oil and gas. But as we all know these are running out very fast and very limited. So we have to find out a new solution like renewable energy, like solar power. It is so important because solar energy is clean, safe, and available everywhere. However, regular solar panels are expensive to make and use toxic materials like lead, which is very harmful to the nature. These are the main objectives of my research: to simulate a solar cell that are cheap, efficient, and completely lead-free. In this work, I used a computer software called SCAPS 1D to design and test a lead-free solar cell to analyze its performance. These objectives help us to optimize the device before actual fabrication. This is the SCAPS 1D setup overview. SCAPS stand for Solar Cell Capacitance Simulator in one dimension. It is a widely used simulation software developed at the University of Ghent, Belgium. Instead of making the solar cell in laboratory, SCAPS allows us to study its electrical behavior through numerical simulations. We can define different material layers, their thickness, band gap, and defect density. After entering all these parameters, the software predicts the electrical performance of the device. This is the problem setup. This slide shows the device structure used in SCAPs. The solar cell consists of different layers including the metal contact, transport layer and the absorber layer. Each layer has different material properties which are entered into the software. Proper selection of these parameters is very important because they directly influence the efficiency of the solar cell. Once all parameters are defined, SCAP solves the semiconductor equations and generates the output characteristics. This is the result overview. After running the simulation, SCAPs provide various output parameters like open circuit voltage, VOC, short circuit current density, JSC, fill factor, and power conversion efficiency. These parameters are used to evaluate the overall performance of the solar cell. In my work, I mainly analyze how temperature affects these parameters. This slide highlights the importance of metal contact layer. The metal layer collects the generated charge carriers and transfers them to the external circuit. Proper selection of the contact layer is essential because poor contact increases series resistance, which will result in lower efficiency. At high temperature. Here I have analyzed the behavior of the solar cell at high temperature. As we know that temperature is an important environmental factor because solar panels normally operate outdoors. So understanding thermal effects help us to predict the stability and practical performance of the device. Let's see the mechanism. This slide explains why temperature affects solar cell performance. As we increase the temperature, atoms inside the semiconductor vibrate more strongly. These vibrations scatter the charge carriers and reduce their mobility. At the same time, recombination between electrons and holes also increases. Because of these effects, important parameters such as open circuit voltage and efficiency may decrease. So temperature optimization is very necessary to design a proper solar cell. These graphs show the variation of efficiency with temperature. As we compare different temperatures, we observe change in photovoltaic performance in different situations. The graph clearly shows how thermal conditions affect device efficiency. Such analysis help us to find out the best operating conditions for maximum performance. So results and findings. A controlled SCAP simulation was performed at 300 Kelvin and 310 Kelvin. At 300 Kelvin, the device showed an efficiency of about 29%, and at 310 Kelvin, the device showed the efficiency which is increased up to approximately 32%. The short circuit current density also increased slightly. This improvement may be due to enhanced carrier excitation and improved charge transport at moderate temperature. Overall, the simulation shows that temperature significantly affects solar cell performance. Let's see the work impact on society. This work is a contribution for the development of environmental friendly solar technology. Lead-free solar cells are safe for the environment because they don't contain the harmful chemical like lead. Since this study is simulation based, it also reduces research cost and time before experimental fabrication. In the future, such devices can support clean, sustainable, and affordable energy generations. These are the major research articles and publications used in my work. Thank you so much for your kind attention.
Thank you so much. Next we have Mr. Devendra Kumar. Next we have Mr. Ayush Chikara. Next we have Miss Shikha. Next we have Miss Preeti Yadav. Next we have Aftab Alam. Next we have Diksha Yajurvedi. Anyone who wants to give their presentation, please come forward.
Who is present?
Okay. Thank you so much for the presentation. As we come to the end of the first day of ICRIST 2026, I would like to express my heartfelt gratitude to our esteemed dignitaries, distinguished speaker, respected session chairs, researchers, delegates, faculty members, and participants for making today's proceedings truly enriching and successful. Your enthusiastic participation and valuable contributions have made this conference a wonderful platform for knowledge sharing and innovation. We look forward to welcoming you all tomorrow for another day of insightful discussions and inspiring presentations. Thank you for being a part of ICRIST 2026. Have a pleasant evening and see you tomorrow. May I request all the delegates, speakers, faculty members, and participants to kindly proceed to the tea venue. Thank you.
खत्म बैटरी भी लगेगी एक सेकंड बंद करो बंद कर पूछ रहे हैं